Okay, great. Thanks, Linand. Very excited to join this conversation. It's my first time really getting to know you guys. And uh, Nicola actually introduced Coda to me, and we thought it would be a great way to start the conversation. So my name is Babak Soleimani. I'm working as a data scientist at HKS. So we're an architecture firm. And I'm working as part of a research team. So HKS has a small research team. Currently, we have 5 people just dedicated to research, and I'm a data scientist on the team. I'm also doing my PhD in architecture at University of Michigan. I'm defending my dissertation next Thursday, so very close. And I've done an undergrad, a master's in architecture. When I was doing my PhD, I did another master's in information science. So that was where I got to know a lot of these data analysis tools, and thought that there's a lot of potential in here. So that's kind of my background. So what I'm going to talk about today is mostly 2 pieces. So it's not a very cohesive piece of presentation, but more of, I'm trying to kind of draw a composite image here of what I see as potential and what we've done. It's kind of intersection between data and design. So first part, I'm going to talk about a lot of my own PhD work. This isn't really related to work we do at HKS, but it gives you some background of like how we can think about using data in design. Second part, I'm going to talk about my work at HKS, and the way I'm trying to frame it is not as here is a product that we have designed, or here is our software, but more to show the process of how we have developed things and how we have worked on different things with designers. So just to give you an overview of how my presentation is organized for today, so you don't get confused. So when thinking about design, I just don't think about data as this it's like a thing which is often shown in a spreadsheet or a JSON file. But any kind of information that we gather from the world is kind of data. So when an ethnographer goes on a site and looks at these different objects that are form of a data, when an architect goes on a site and looks at the slope, that's kind of a data. It's a qualitative data, but that's still kind of a data. And then we have another way of looking at it, which is a more that's what we often nowadays we refer to as data, which is this kind of quantitative and numerical kind of data that looks at the space not through this lens of sitting down, touching a stuff, kind of getting that close connection, but trying to kind of getting this big picture of a space and of a location or a space, and trying to understand it that way. So it's I think both of them are valuable in their own ways, and our understanding as architects and the designers is always an interaction between the 2 parts, between this kind of quantitative understanding, this big picture understanding, and then this more qualitative, more tangible understanding, which comes from interaction, more close interaction with objects. So that said, I've been thinking about, so when I was doing my PhD, I was thinking about what are different ways that we can really collect this kind of more qualitative data from about our locations, about the places that we inhabit as cities. And so School of Information in Michigan is very heavily focused that we have a lot of faculty that do work on social media. I was taking courses on social media, And then I came across some pretty interesting concepts in social media analysis, which is we can kind of look at the city, we can look at the space through the lens of social media. So there are a lot of apps. This is an interface from Swarm, this app that used to be part of Foursquare, but is now a different app that you can use to check into places. So you go to a coffee shop and you check in and say, drinking coffee with my friends, and or you can tag a photo you post on Instagram, or you can review a location, a restaurant on Yelp. So all these social media websites are basically footprints that we leave on digital space, but they all have some footprint in actual world. So when you leave a comment on Yelp, yes, it's a digital medium, but at the same time, you are talking about an actual physical space. So that means we can look at the city, we can look at the built environment through these digital footprints. So there are three different types of data online. You can think about other ways of categorizing this. This is just the simplistic way for me to think about it. So there is spatial data, which is just latitude, longitude, or location. There's textual data. You leave a comment, you leave a tag, and then there's visual data. So you take a photo, you take a video on Instagram, on any of these other apps. So I've been trying to, I didn't really look into visual, but I did like 2-3 different studies with spatial and textual data, just thinking about how we can use this data to think about city, to think about built environment. So the problem with this kind of data is that there's a lot of data out there, but it's very messy and it's mysterious, and it's not like a survey that you go, you send out a questionnaire and then people fill out the questionnaire and it's structured, it's nice, ready to be analyzed. It's a bunch of people just leaving comments on a travel website or on Instagram. It's not meant to be for research or for understanding. So there's quite a bit of work to be done before we can actually get anything out of it. But the question is, like, can we use user-generated content, like this kind of content or data that's generated by users, along with these other forms? It gives us a massive scale that you hardly can get from any other method, but it has its own challenges, as I said. So mainly focusing on textual data and geographic data, and kind of looked at different ways of analyzing data. So there is analyzing natural language. So when you don't have a clean data set, you have to be a bit creative and think about different ways you can actually work with it to make sense of that data. So there is lexicon-based analysis, which kind of looks at the syntax of the text and tries to kind of extract useful information. There's topic modeling, which tries to extract themes from a text. There's sentiment analysis that tries, that's kind of an attempt or a technique which you use to understand what's the sentiment around the text. Is it happy? Is it angry? Is it sad? So there are just different techniques, and I've used them in different projects. So I'm not going to talk about all projects because some of them are just the 2 projects that I'm going to show are more related to design and kind of evaluating something that can be addressed. There are other projects that are more theoretical that I'm not going to talk about. And I'm using Python. So I used to use Python. I'm not using 2.7 anymore, I promise you. But using Python with NLTK, which is a natural language toolkit with Python, and then sometimes using scikit-learn, the machine learning tool. I think I didn't use scikit-learn for any of the two projects that I'm going to show. They were these two projects are more simple analysis. So this first one was museum navigation. This was basically coming out of looking at TripAdvisor website. So TripAdvisor is a very interesting website because people go on it and basically review places, and it's not necessarily reviewing businesses. People review museums and like interesting places for us, like parks or public spaces, places that are related to travel in any way. Stadiums, like any place that you visit when you have a trip. So and data sets are for museums. So I just looked at like what's going on TripAdvisor, and I found out there are massive number of reviews for these museums. If you go, I think this screenshot is from 3 years ago, but if you go now, some of these have more than 100,000 reviews. And I don't know why people really put them, like write reviews after 100,000 reviews, but they do it, and I appreciate it. But so they do these reviews, and so they talk about different stuff. I just try to. These projects were super exploratory. Just trying to see what's going on and figuring out if I can get anything out of it. So when you look at different comments, you see people talk about different stuff. They talk about navigation. They talk about, like how good was the collection, how beautiful is the building. But the number one topic that they talk about is navigation, which is interesting to think about in any way, because that's something interesting you can get out of this data, because you see people when talking about a building like museum, number one thing that comes up is navigation. That's the highest use theme that's going to emerge. And so I said, okay, that's interesting. So let's look at some of these navigation problems or issues in here. So I look at like what different words are people using. They're using words like layout. Is it a confusing layout? Is it easy to follow? Is it difficult to navigate? So these are the kind of words of interest that I look for, and then seeing what kind of adjectives were used with this. So is it simple? Is it easy? Is it confusing? So some of these adjectives were positive, like simple or easy. And then some of them are negative. Is it confusing? Is it difficult? So you can basically assign a positive value for any comment that has positive adjectives, and a negative value if the comment has negative adjectives. And then analyze the museum based on it. So if you have a museum that has this word, like 99% of people have used these words, you know that it probably have some serious navigation issues. So based on that percentage, I define like a wayfinding grade for each museum. So I picked the top 10 museums with like top 10, I mean, not the best, but the ones that had the highest number of comments. And just give them a wayfinding grade based on the percent of positive or negative adjectives that they got. And you see that they're varying in degrees. But after doing this, I thought, oh, but does it really make sense? Because, I mean, this might be just totally nonsense. This might be just number. And then that's when I kind of plotted this wayfinding grades against the size of a space. So something that we know from wayfinding literature is that the bigger, I mean, this sounds really obvious, but the bigger the space is, it's harder to navigate often. I mean, there are other factors play, like layout or signage, but let's say the kind of rule of thumb is that the bigger the space is, the harder it is to navigate. So I plotted the wayfinding grade against total gallery area, and then as you can see, like there's a pretty high correlation between the two. There are two very interesting outliers, and I think that's where it gets interesting, because now we can go and say, oh, Royal Ontario is not much smaller than Pergamon, but it has much worse navigation grade. And then when I looked at it, it was a lot of people. I said, okay, Royal Ontario probably has something serious going on. So when you look at it, you find out that because the Royal Ontario Museum has these two different wings. That the new one designed by Lipsky, and the older one is a historical building. People get really confused between these two different layouts. That's why it's kind of an outlier. So this probably doesn't have a ton of value, say from perspective of wayfinding literature. It doesn't really add anything to wayfinding literature. But it's interesting that we can get all these values and data from just a website. If you wanted to do a survey, a questionnaire for this space, it would have taken months. Amount of money that you needed to spend on it would be ridiculous, and it's just this is probably like 5-6 hours of coding, maybe less if you have the data. So this was one example. The second one is more of an urban scale project. So I've been looking at this. This is one of my Jack Nasser is a very interesting author. He has this very interesting ways of translating qualitative frameworks into quantitative measurable frameworks. So he's one of those people who tries to kind of quantify beauty or image. This is stuff that are not really, we don't think about them really quantitatively. Jack Nasser is a person who tries to translate them into quantifiable measures. So he has this very interesting book called The Evaluative Image of the City. So what he has done is, and then I've tried to kind of make it user generated, but what he has done is he just goes to two cities in, I think it's Tennessee, I can't remember exactly. But he asks people like, which part of the city, which parts of your town do you really like, and which parts of this city you don't like, image-wise. And then he finds out, okay, here are the areas that people like, here are the areas that people don't like, and then asks them to, okay, why don't you like this area? People say it's because it's congested, it has a lot of parking, so it kind of puts them in two different, like positive category and negative category. So he puts 5 different categories. So naturalness is one, which is, so if you have vegetation or water, mountain, this is positive. If you have industrial image, if you have, signs like billboards, that's negative. Upkeep and civilities, that's another category. Openness, is it open? Is it congested? And is it historically significant? Do you have nice, beautiful historical buildings or you don't? And then is it ordered or is it chaotic? So his framework can be criticized for sure. Like it's a very normative way of looking at beauty for sure, but it's something to play with and think with to start with. So that's the way I didn't really criticize the framework. I thought, okay, now can we really use something else, another data set in a much larger scale that he has used, because he has done his interviews in very small town. Can we do it for a large city like Manhattan with a much larger population without doing interviews, without doing surveys? So I use data from Flickr. So Flickr is, for those of you who don't know, has this photo sharing data set, photo sharing website, sorry, not data set. So a few years ago, they put out this data set with 100 million different images. It's just for people to analyze, for researchers to look at. So I looked at the data, seeing what's going on. So I found out like about 19% of images are geotagged, so you can actually find out where a photo was taken. And then one nice thing about Flickr users is that they tag their photos a lot, because a lot of them are photographers who want to be seen. So they tag their photos a lot. So when people search for tags, their photos come up. So that's one nice thing about Flickr. But the thing is that these tags were not really meant to evaluate an urban area. When Jack Nasser was doing his research, he just asked people, what do you like, what you don't like. These tags are just, to make the image more searchable or more easier to extract. So I needed to do some adjustments. Like you can't really translate what he has done to what we can do with this. But so you can see with an image in Manhattan, you have images that are tagged with people, a skyscraper, building, sign. So that people tag what they see in an image. So that's interesting because that's what we need basically. That's what NASA's framework is. It looks at objects or perceptions in an image. So when you have tags with Central Park or outdoor, so that's what we need. So I kind of did a bit of cleaning and finding out, okay, so for naturalness, what are the words that people use? Not all of them connected well with what NASA was doing, but some of them did. So for naturalness, we have green, tree, garden, negative. We have some of the stuff that NASA had. And the same goes for historical significance. People use different words, openness, and I had to combine these two categories because there was not enough data for upkeep and order, because there is less of subjective evaluation in Flickr. People don't talk that much about, is it beautiful? They say there's a tree in this image. They don't say that much that it's beautiful or is it attractive or whatever. So here's the all geolocated photos that I gathered from Flickr. So what I did was, for any of, so say with some of these so blue ones are say positives, red ones are negative, but how can you really visualize it? So I put a grid on it, and then with each grid, just positive tags around. I just counted positive tags around it and negative tags. And then if a point in a grid has a lot of positives around it, then it becomes really positive, and then we give it a large radius. And then same goes for negative. If it has the same number, we just give it a neutral value. So you can see this one had a lot of positive around it. This had one negative around it. So this is a big green. This is a small red. So for naturalness category, these are all the photos that we have. All the geotag photos that we have for naturalness. If we organize it based on this positive negative thing, you're gonna see that you have really positive values in Central Park area, around the Manhattan, especially where you have a good, nice view of river. But then as you get to central Manhattan, you get worse. I mean, it's expected because you have less of nature and then you have more of city. So you have more signs, more billboards, more industrial image than in Manhattan. Not necessarily industrial, but not as natural. And then with historical category, we don't have really negative, but we have kind of lack of historical buildings. So this is the kind of the opposite, because as you go more central in Manhattan, you get more and more historical buildings. And so upkeep, order, and visual category, you see it's not as populated as the previous one. We don't have as many data points for this. And then openness. So if you put them all together, this is the image you get. So this is for all tags in the city, based on negative and positive. So Central Park is doing really good. Around Hudson River, around these areas, it's doing fine. Where Battery Park is. As you get to the more Central Park, it's not doing great, but there are areas that are doing good. They have a still positive image mixed with negative image, but they're still positive. I think that's that's where lack of naturalness was compensated by beautiful buildings, ordered part of the town. And so it's kind of balanced off. And then and then here in the top, you get this with this park up here, you get also positive. One area that is constantly negative is here. And not surprisingly, that's where has a lower household median income in Manhattan, and that's so. This is kind of trying to, again, this was a way for me to think about it and verify what was the result of this analysis, which is, oh, that's, I mean, again, it is not a contribution because everybody knows, okay, like if you have in Manhattan knows that north of Upper East Side, Upper West Side, isn't as say wealthy, or as buildings are not as beautiful as in other parts of Manhattan. But just trying to verify that does this data really make sense? Is it something that we can use for future? So if it's not Manhattan that everybody knows about, if it's another city, we're trying to kind of understand what's the image of that city. Can we use it? And it's I mean, for sure you need much more rigorous ways of verifying this data. But this was for me just an initial way of okay, it's not nonsense. At least there's some value in here. So changing gears to HKS work. This was all my kind of hobby projects when I was doing my PhD. But when I started working at HKS as an intern summer 2018. Worked for about 6-7 months, then went back to school for 6 months, and then joined more than 6 months. I joined back in October as a full-time data scientist on a team. Probably a lot of you know HKS. We are an architecture firm. We do a lot of NFL stadiums. We did US Bank Stadium. We are doing Rams, which is the next year Super Bowl stadium in Los Angeles. We do a lot of medical buildings. We have a research team. As I said, there's 5 of us at this point. We have psychologists, data scientists, ethnographers on the team. So it's a very, very interdisciplinary team. This is our lab space down in Dallas. It's a pretty big space that we use for prototyping new ideas, for building stuff. So it's a very interesting space. So there are a few components to our team. We have Cadre, which is Cadre is part of us, which is a nonprofit run by HK, and so that's going to be used for some of our research projects. We are doing this project called Living Lab. We are using our own offices as a kind of way of understanding a space. So when we move to a new office, we start collecting data of how people use their space, how people understand the space. And then one of the interesting projects that we did that just recently won the Interior Design Award is Sensory Wellbeing Hub, which we did in a high school in Chicago for high school kids that have kind of sensory issues, and then kind of helping them to decompress when they have them being overwhelmed in a classroom. So these are some of our projects. There is another component of HKS called LINE, which is Laboratory for Intensive Exploration, that doing a lot of our computational stuff. They do optimization. They do very complex modeling and fabrication. So that's another component. We have other research component, LOGE, which is our sport advisory. I won't go too much into detail, but just trying to give you a sense of it. So what I'm going to talk about is my experience as a data scientist / developer in this team, and kind of saying what is unique about it. What was the thing that I kind of think is different about it, and what's good about it, what can be improved. So I worked when I was doing my PhD. I interned in a couple of software engineering companies. I worked for Ansys, which is this software simulation company. I work for a game company. So when you think about those companies, you have a full team of, a product manager, you have UX designer, you have developers, you have data scientists. So you have a full team. And then between this team and customer is often like a market researcher or UX researcher, people who try to kind of understand what's going on with customers. And then you have your customers that you design for, whether it's a software or it's a product. So there is this kind of hierarchy. So when you're an architecture firm, you often don't have that luxury of a full team, right? You don't have, I mean, there might be examples that I'm not really aware of, but most of times there are a few, and there are, because we're growing, it might happen in the next few years. We might have like full development teams on architecture firms, but right now, we usually have these kind of unicorn people that have studied architecture and then have done, have studied some computational design on their own, or have studied some, have another degree in say, computer science or in information science, and they kind of work not with designers, which are kind of their clients in a sense, not as a client, but they kind of work together. It's a very close collaboration environment. So you don't have all the fanciness of software development company. But the good thing is like you're kind of working directly with your clients or with your customers. And they're not really customers. So you're part of the team. It's as if in this model, customers were part of the ecosystem, like not through UX researcher who goes on a site and interviews and does survey, but imagine having a customers actually in your headquarter. I think that's the beauty of it, and that's what I've kind of really enjoyed doing, which is this: you get quick feedback. If you're doing something wrong, you just get quick feedback. You go back to your whatever software you're using. If you're doing Grasshopper, if you are opening your Python debugger or whatever that is, so you go back to, and then you get instant feedback. That's a very nice thing. So I like this interaction is something that we can embrace, I think, and we can look positively at. I mean, yes, it's frustrating that you don't have sometimes that we don't have like a software developer that can do things quickly. So I'm going to talk about this process of interaction that I went through with a product we had, and not talk about the product itself that much. I'm going to touch quickly talk about it, but just seeing like how this interaction is something that is kind of beautiful about being a computational designer or a data scientist or a software developer in these companies. I'm going to quickly pass through this, so if we have time. So this is like just a very, I have to probably talk about this quickly, but this is a very overall overview of what our tools or what we develop mean to our design and research. So we case tries to be a research-informed design firm. That's what we can aspire to. So design is at the core of our practice, and is always informed by evidence-based frameworks. Especially our healthcare practice is highly evidence-based. A lot of our designers have great knowledge of evidence-based frameworks, and they've done a lot of different certificates. So they kind of use that knowledge. But at the same time, that's kind of the general knowledge that we bring to a project. So but the thing is, with every project, we need to gather contextual data. That is, not two projects are the same. Every project has a new component, and that's where we need to have other tools that allow us to gather data on this context. So that's where kind of our predictive, or diagnostic tools come in, trying to kind of understand, making sense of a situation, and predictive tools that trying to kind of predict what does our design solution mean for a situation. So predictive tool is basically a simulation tool. That's what we do say with like energy simulation or a structural simulation. We do it also with a lot of our human behavior factors. And then after we're doing our analytical, we have the results or we have gathered the data, we use some analytical models. This is a model that we use to interpret the data with. So because data doesn't really mean anything unless it's interpreted. And then ultimately this interpretation goes back to design. One part that we haven't really invested in, but it's something that we're looking at, is generative tools. This is Copilot with design. A lot of you probably know way more about this than me. But just think that there are these three different components that interplay. So this kind of evidence-based frameworks, knowledge, analytical models, the tools that we use to gather data, simulate, and then models that we use to interpret. So the tool that I'm going to talk about is focused on this diagnostic and predictive part. It's a tool we call Onion. The reason we call it Onion is that it's kind of layered. We thought about this tool that has layers of, and kind of shows us different layers of a space. So these layers are the data that we collect from, say, how people use a space, what are the activities, what are the occupancies, and then also other layers that come from analyzing the space geometry itself. So we think about it as like this relationship between patterns of people and patterns of space. So I developed this tool when I was an intern. We made it to a semi-software. It's a desktop software. It has different modules. So if you want to run an analysis on occupancy of a building, you have your data, you give it to it, it kind of processes the data, gives it back to you, and visualizes it. Or if you want to run, say, visibility analysis or connectivity analysis, you can use the software. So I won't go through this too. So a lot of things that I was using for this software for the predictive part was coming from a space syntax literature. A space syntax is this body of knowledge that tries to predict human behavior or human perception using the layout of a building. So it looks at kind of how visually connected a space is, or how connected different spaces are, and predicts what's going to happen. So I started with this. I just implemented some of those techniques into our tool, saying very basic stuff like visibility and integration. And for one of our projects that came up to me and said, "Oh, we've heard that you have this new tool. We are excited to use it. And what can you tell us about this hospital layout?" So they gave me a hospital layout, and I ran the visibility analysis, and then I showed them this image. These green areas have higher visibility. They can be seen from, these are just hallways of the hospital. These are rooms around it, and then these are just hallways. I said, yeah, these areas can be, have higher level of visibility. And then they came back to me and said, "Oh, cool, but what does it mean? What can I do with this?" It doesn't mean anything to design. It's an interesting visualization, but so I didn't really do much after this. I just said, okay. They had different options, and I ran it for like 3 different options, and said like the best that we could get out of this was, with these 3 different options, you get like this one is more centralized, so you have high visibility areas, and but with this one you have less visible, like you have more areas that are visible, but they are more distributed. But at the end of the day, it really didn't make that much of a difference. So I thought about it that this was the quick feedback that I'm talking about, that I got this really quick feedback that this doesn't really do anything for design. So maybe we can do another thing. So talking with designers and kind of understanding them, we realize that what's important to them is not just the visibility of corridors, it's how visible are beds from corridors. So if you can see a bed from, like, if there's a very strong literature that visibility of a bed has a high correlation with the mortality rate. So if a bed is not visible, nurses won't pay as much attention. So what we did was, so okay, I said instead of focusing on hallways, we can focus on just the beds and then get that number. And then when I ran this, so for the second time that they came to my, thanks for them to trusting me again. But we ran this analysis, which was how visible is each bed from nurses station. And then they could find out, oh, these are the beds that don't get a lot of visibility, so we can, or then don't get good access, so we can kind of change it. So this became more meaningful. So then another project came up, and it was same question, visibility to patient beds. But here was another problem. This wasn't just partitions, there were transparent layers in the space. So it didn't really make sense to run the old analysis. So we kind of modified it a bit now that these areas, outpatient units, inpatient units that have like a semi-transparent half-height partitions that had higher level of visibility, had like a medium level of visibility. So this became like an additional tweak to the tool, and then use it later with other projects. So these are, so just to make it more clear, these are nurses stations, the blue stuff in here, and then the other ones are patient rooms. So you see like the ones that are next to a nurses station have higher visibility. They're green, but if you are here, very isolated, you get red. So and now, so with this one, so with the next one, so we had another client who designer came back and said, okay, we have this client. We want to, we are proposing that in this outpatient unit, there are two different pods. Like this is one pod and this is one pod. And then we know the nurse or the doctor is gonna move around these two pods. So we want to know what happens if we so if a doctor, and these three rooms in here and these three rooms in here are nurses stations. So we want to know what's going to happen if we open this hallway in here and make a connection between these two rooms, these two pods. Like how is that going to affect? And this was something new because like how are we going to show it? And then they wanted to say, does that really make financial sense if you do it? How much does it really impact the walking distance from here to here? So we kind of ran the analysis and then did this drawing to show how much how much adding this hallway reduces the walking distance between the two pods. So for any of these two, so you can see like between these two options, a lot of them turn green because so for this one, say if you want to walk from here to here, you have to go this, but with this, you just quickly access it. So you can see some of them are radically, like some of them go 20%, 25% down. And it was something that we could use when talking with client to really justify this decision. So this one was interesting. This is, and I think this was the more interesting one because the designer that I was working with wanted to had a kind of, this was a bit of a complex issue because this was a acute center patient unit. So these two rooms that you see in here on the left, they are the acute patient. The other ones are regular. So the question was, okay, if we place the care team here at the center, then we're going to have a lower walking distance for a lot of these people, right? So if you put it here, it makes a lot of sense. Every bed is really close to this, except these two. But overall, it's doing better. And then with triage in here too. So if we think about this as a core. The problem is if you put the care team in here, they don't have visibility to acute patients. So the patients that need it the most actually get very small visibility. So that was so the designer was saying, asking me like, okay, here is a dilemma. This is a question between visibility and walking distance. So if we put it here, then we're gonna have a small walking distance, but low patient. If you put it here, we're gonna get higher walking distance, but very good visibility to this room. So the client really kind of asked us how is going to make a difference. Okay, if we place it here, how negatively is going to impact the walking distance. So we wanted to know what's the trade-off between the two. What's the trade-off between walking distance and visibility in this specific case? So when we ran the analysis, we find out that actually putting it on the next to the acute patient room doesn't really increase the walking distance overall that much. It's something around maybe less than 2-3%. So it's like average walking distance went from 20.32 to 20.82. That's like very small. But you can see that these two red lines are acute patient rooms. So you can see that visibility for them is much better when you go with this option, which has the ketamine. And these are the rooms that actually need the visibility more than any other room. So yeah, so we could, getting this feedback with the designer gonna help us to make it more meaningful. And then the client can understood that with numbers, we could really justify our design decision. These are a couple other projects that, a couple other projects that I'm going to show how we use this different this tool, and I'm going to wrap up. So with this office, as I talked about the living lab office spaces that we have, these are our own offices, and so every one of them have like some scenario to them. So for our Chicago office, we had this idea of this space is going to be our space at the end. So you enter from here. These are all the design like design desks. People sit here, and then at this end there was kind of gallery kind of a space, which we expected people, or the design intent was to really for people to gather in here and have design discussions. When we actually collected data, I found out that it's not really working that way. It's not being used that much. So this is the occupancy data. You see if the color is light, it means that lower utilization. So when we ran the integration analysis, so one idea was like, why is it not working? And when we ran the integration analysis, another space syntax technique, and I said, this is probably not working because it's in a very segregated area. It's not a very well connected area of the floor plan. So they changed so it's a living lab, so we can change the it's our own space. So they're gonna change the function of that space. Another this is the last project. Another project we did was for a venue. This was a stadium, and we wanted to understand like what are the bottlenecks in a space. So and then why are they bottlenecks? So we collected data on where people walk and where people I'm sorry, I forgot to tell this. This is the food court area of the stadium, one of the concessions, and so we collected those data and we saw that actually where people are queuing for food is the same as where people are walking. So we saw really we saw a lot of congestions in these areas. And then when we ran the integration analysis, we found out that, oh, interestingly, one of these food queues are in here. And this is the most integrated part of the space. It's the most connected, has probably the highest foot traffic. And we saw that it has a pretty high foot traffic because anyone who goes from here to here has to pass through this. And there's a food queue always in here and people are passing. So it became kind of an with designer, we kind of thought about it, and so we went back to the client and said maybe the idea would be in here to kind of relieve this bottleneck in here, to extend, because there's a void in here, and then kind of extend this into here and give it some more space, at least to give some relief to the bottleneck in this area. So just to wrap up, through these interactions with designers, I think I thought about 3 different ways to communicate and work with designers. Kind of the analytics or data can work in 3 different ways. One is on the identifying opportunities for improvement. So like that was the first project that the second one actually that I showed, which is you analyze a space, you show them, oh, like this. So in the case of like if it's an inpatient unit, these beds are working well, they have good visibility, but these are not doing as good. So you can do something about it. The other one is testing design options. So that's what, I mean, this is what we always, like a lot of designers do with, say, energy testing or with structural testing. So you can also do it with the kind of analysis that I showed. So you have 2 design options. You want to see which one performs better in different dimensions, and then designers can and researchers can think about which one is a priority. And then finally, scenario testing, which is every design is a scenario. It's a story that we tell. We think, oh, this is going to be gallery and this is going to plaza, people going to gather in here, but is it happening really? And that's kind of the scenario testing component that I showed with our living lab and with the venue that I showed at the end. So you can test those scenarios with data, verify them, or say, oh, it didn't really actually work the way we thought. This is the reason we think it didn't work that way, and maybe possible ways to fix it. So almost 7 o'clock. am I on time? Leland, I'm done here.
That was awesome. Thank you so much.
Yeah, sure.
We were planning to spend an hour on the design forum, but I would love to give everyone a chance for Q&A. Does anyone have any questions they want to ask? I guess I'll kick it off. I found it very interesting that you were showing a lot of metrics that I've never seen before. And I wonder, how do you, knowing that you can do so much in leveraging and calculating all kinds of things, but how do you identify what's the right metric to measure?
Mm-hmm. So are you asking about a specific project, or?
I guess just in general, for somebody with you've got such a skill set, but I feel like the designers need to assist with identifying what that metric is. So I wonder how that interface between a data expert and the designer who knows what their problem is. How do you identify the problem to solve?
It's often a very collaborative process. We kind of get into a conversation. We bring in our research practitioners. So a lot of our designers actually have a very good research knowledge. And they already, I mean, we call them research practitioners, actually. So because they have the great research knowledge, but they also have great design skills. So that makes them really skilled for starting that kind of conversation. So we get into conversation, we get into a talk that, okay, what is that we're trying to measure in here? What is that we really try to understand in this problem? And a lot of time they bring up the right way to think about it. So the specific project that I was showing with half semi-transparent partitions, that was the designer who brought up the idea that we can assign different values. So it's an interesting process, because I'm a data scientist on a team, but I'm coming from a design background. Our designers have research background, so we kind of meet halfway, kind of make it work. Does that answer your question, Leland?
Yeah, totally. We've got like 25 or so people on the call. Anyone out there have a question? You're all muted, so if you're asking anything, make sure you're on mute.
Yeah, I had a question. Maybe if you could weigh in on what ends up being the governing factors on the quality or the impactfulness of of these studies. What what is the I guess what's the most important part to get right to make sure that the studies, this data analysis is really giving you the information and the impactfulness from that information.
So is your question that like what as a researcher or a data scientist or a computational designer can do to make sure that your analysis is getting things right? Is that like, getting things right meaning uh, your analysis really reflects what's happening in the design?
Yeah,
Or
I think it's more what makes the analysis have a level of quality where it can be impactful to the design. So, um, uncovering things that maybe were harder to uncover with just kind of anecdotal
Mhm.
understanding.
Yeah, I think one part, the very important part of it is for it to be based on good literature. So for any of these measures, if you're talking about visibility, for instance, we talk about visibility in hospitals, there is a good body of literature that supports those metrics. And you have different types of visibility, and visibility can be, moderated by different factors. So I think kind of understanding those metrics from literature and finding out what is the right metric to really choose in here from that literature is really key. Um, so there's a lot of time when we start a new project, we have to go back, open up some of the studies and say, what's going on in the literature on the literature side of this. And then when we kind of discover that, we might compare different metrics and then seeing which one is the one that is most supported by the evidence, by the literature, and then using that in our work. So does that answer your question, Eric?
Yes, it does. Thank you.
Yeah, sure thing. I see another question. Asking, do you mind elaborating on predictive and generative tools shown in the previous diagram? So that diagram is a work in progress, and I think I would be happy to hear ideas, like if you have suggestions on it. But the way I think about it is, and I think predictive tools and generative tools are very interconnected. But predictive tools are kind of computation, like the tools that we use to predict what's going to happen to a space. So energy simulation model is one example, right? So when you run a simulation, you expect the building to perform in a certain way. Or the same with a structural simulation, you expect the building to hold itself. So so with some of this, so that's the predictive part. Generative is when you use that maybe and it's always based on a criteria. So in any case, for your predictive tool, you have some sort of criteria. So generative tools are basically the kind of tools that we use to generate options. So they are not really to test. They are again, they often use some sort of metric and values because you can't just generate everything. But so generative are I'm thinking about like the tools that you use to generate spaces or structures or any kind of spatial formations. I think they always speak to each other because when you generate an option, then you need a predictive tool to kind of predict what's going to happen with that space. So they always need to speak to each other. But I'll be happy to hear if people have better ways of thinking about it, because this analytical predictive generative is coming from the data space, maybe doesn't translate as well in the architectural space. So have you, oh, sure thing. Have you done any post-construction validation? If so, any surprises? I can say with our living lab, we are doing some of that post-construction validation. And yes, it's always full of surprises, and I think that's why it always has to be a cycle of uh, uh, making this hypothesis, thinking about a scenario, trying to kind of validate it, and going back. When I'm thinking about it, is that so in the software world, we always have this A/B testing, or we can have this very quick user feedback. If you're, say, Spotify, overnight runs a new code, and then everybody have the new software in their phones the next day, and then they can quickly collect data on what's happening. And then if it didn't work, they can just change it. It's a CSS code in the background, or an Angular code in the background. With us, it's quite difficult because that cycle for us to happen. A hospital takes quite a few years to be built, or a stadium takes a few years to be built. So that's quite a slow. That was the idea behind Living Lab, because that's HKS space, and we can make small changes. It's not a totally new building, but at least gives us some form of some possibilities for testing ideas. So the example I showed you with Living Lab, we kind of tested a new idea, and now we're collecting data on it. And if I go to the last question, which kind of tie it back to your question, now we are using sensors to collect very granular data on how our spaces are being used. So we are kind of testing with sensors that collect with real-time data collection, and trying to see if the changes that we make in furniture, or our changes in policy, our changes in like adding new partitions, does that make any difference? Unfortunately, as soon as we installed the sensors, this whole coronavirus happened, and then nobody's working from an office. So unfortunately, we are not collecting any data at this point, but we hope to start collecting data soon again. Okay. With your analytics, what informed the decision to develop a software as opposed to using typical computational tools as we know, Grasshopper? I think that's a very, very good question. And how do you integrate with design software? That's a very good question. The reason that we didn't do, say, a Grasshopper tool, which probably makes sense for software analysis, was that before, so there were a lot of things going on before we started doing Onion. So there were for research practitioners that were collecting data in hospitals, behavioral data. They did behavior mapping using software called Bluebeams. So that was one thing. So that was one component. There were these other people who were using Excel sheets to do shadowing. So shadowing is this practice in healthcare, which you follow a nurse or a doctor throughout the day, seeing what are their activities. So that was the second part of it. Third part was we had some of our teams that needed a tool which gave them the kind of some programming capacities. So if you look at the space, they wanted to see we use a framework called Me v Us, which is like you want to see spaces that are individual, spaces that are collective, and spaces that are collective work. So social, sorry, individual, collective, and social. And so that was the third component. The fourth component was this spatial analysis tools that we want, the spatial analysis, as space syntax components. So there were all these moving parts. I think we kind of talked about it, and it didn't really make sense for it. Grasshopper didn't give us the tools to really do all of them at the same time. We needed something that kind of brought all these pieces together in one cohesive tool. So, but then at the same time, it has its own challenges, because if it was a Grasshopper tool, then it would be easier to use, say, with a new analysis. So if you had floor plan, you could just quickly do your analysis in Grasshopper. But now you have to kind of export it and use Onion to analyze it. So it's not as convenient. So it was, it was a kind of trade-off between, do we want, because I think the idea of having that layered analysis was the most important thing to us, and wanted to have all the layers in one tool. It created some inconvenience and created some, inconsistencies. But yeah, that was the reason behind the decision for us. Does it answer your question? Okay, thank you. And Everett, okay, interesting hearing more about method and technology that you use to assist in data collection. So this is a very good question. We started, so I probably should say a history of data collection methods we have used. So it's been going from, say, pen and paper at some point to Excel sheets for, say, shadowing data. Just one person having an iPad and putting down data points in an Excel sheet, and then to Bluebeam, the tool that people use for annotating construction. I mean, that's what it's usually more used for, to annotate construction documents. So we used it for behavior mapping. Recently, we have started deploying sensors. So we have used sensors that gives us automatic data, and which is very convenient. And also looking at, for larger scale, for urban scale, we have started looking into, and for some of projects, using social media data. That was an option. And also using these services that give you location data. So that's usually from phones, anonymized phone data. That's our most recent attempt. But I would say, like, it depends on the project. So with sensors, say in a hospital, at this point it's very hard, very hard to use sensors. There are health concerns. It's just not not easy to really install them. And then or if you think about like a stadium, a scale is so massive that it's hard to use sensors. So geolocation data may make more sense sometimes. So it depends on a lot of things. How is the privacy protocol in that space? How big is this space? Can you even do pen and paper? So it's always, we think about these different things, and in some cases, pen and paper is the best option. In some cases, sensor is the better option. In some cases, geolocation data is a better option. So we just have to find out the right balance again. Can you talk about where and how our sensor is set up? So this is one of our offices. So that's where we are setting it up. So there are quite a few products on the market. If you look at them, so one is kind of mesh thing. So they are installed on the ceiling. So you have like a grid of sensors, and then they give you, so they work based on movement. So they're similar to the ones that like just automatically turn on or off, turn on your lights on and off. So that's how that one work. There is this other one that are installed under the desk. So they are, so if someone is using a desk, you can say if they're using a desk. So what else? There are ones that use cameras. Not really recommended. All the privacy concerns. It's not really. And yeah, so there are ones that use sound technology. working just based. They're very sensitive to sound. But these ones that I'm talking about, the ones that use that are using infrared, those are not that. I mean, they're. I mean, most spaces are fine to use them. There are very little privacy concerns, so they're a safer option, I would say, compared to anything that can collect data that later can be used for other purposes.